Ever since Donut Lab announced its revolutionary solid-state battery, the internet has been divided. Some people believe it's a breakthrough. Others think it's simply a capacitor, vaporware, or even a scam. But when you look beyond the headlines, the story becomes much more interesting. Donut Lab claims its battery can deliver around 400 watt-hours per kilogram, which would put it significantly ahead of many of today's best lithium-ion EV cells. The company also says it can charge from empty to full in roughly 5 minutes, last for an extremely long time, and do all of this without lithium, cobalt, or other scarce metals. If those claims are accurate, the implications could be huge. A battery made from abundant materials could reduce dependence on today's battery supply chains, while higher energy density could mean electric vehicles with much longer range without adding extra battery weight. And 5-minute charging could make charging an EV feel much more like filling a conventional car with gasoline. But there's an obvious reason people are skeptical. We've heard extraordinary battery claims before that never became real products. In 2007, Store claimed it had developed a solid-state capacitor with energy density of around 385 watt-hours per kilogram, a charging time of only 6 minutes, and a lifespan of roughly 1 million cycles. Those claims generated enormous excitement, but the promised technology never became a commercial product. Then there was Fisker. In 2018, the company announced plans for solid-state batteries and expected the technology to arrive around 2020. That never happened, and Fisker eventually filed for bankruptcy in 2024. So naturally, people are asking whether Donut Lab could end up following the same path. There is, however, one important difference. Donut Lab says its technology isn't just sitting in a laboratory. Marco Lettimaki, the company's CEO and chairman of Verge Motorcycles, has said the batteries are already being used in Verge motorcycles, with customer deliveries planned for 2026. Lettimaki also has experience in technology. He previously founded AppGyver, a no-code software platform that was acquired by SAP in 2021. His brother, Tuomo Lettimaki, has been CEO of Verge Motorcycles since 2019. That connection matters because Donut Lab originally came out of Verge. Verge is already known for doing something that once seemed highly experimental, building production motorcycles with hubless wheels and integrated electric motors. Donut Lab was spun out of the company in late 2024 to commercialize technologies developed for Verge, including its battery and wheel systems. So the question isn't whether Verge can turn unusual technology into a real product. It already has. The bigger question is whether Donut Lab's battery can actually deliver the numbers being advertised. When the battery was first announced, there was very little independent information available. Donut Lab had not clearly revealed its chemistry, manufacturing process, or production facility. There were also no substantial third-party test results available at the time. That made the skepticism understandable. But things have started to change. Over the past few weeks, Donut Lab has gradually released third-party testing, giving us more information to work with. Those tests could eventually help determine whether the company has genuinely developed something revolutionary or whether the headline specifications need to be interpreted differently. And this is where the story gets interesting. There are several theories about what could actually be inside the battery. Some suggest it might be closer to a capacitor than a conventional battery. Others believe Donut Lab may be combining multiple existing technologies in a new way. The important point is that dismissing the battery as simply impossible may be premature. At the same time, accepting every number at face value would be just as premature. A battery that delivers 400 watt-hours per kilogram, charges in 5 minutes, lasts an extremely long time, and uses inexpensive, abundant materials would represent a major technological breakthrough. But making those numbers work together at commercial scale is the real challenge. That's why the upcoming evidence matters more than the announcement itself. Donut Lab has made some very big promises. Now it has to prove that those promises survive independent testing, real-world use, and eventually mass production. For now, we don't have enough information to say exactly what's inside the battery or whether every specification will hold up. But we do know one thing. This story is more complicated than simply calling Donut Lab's battery a capacitor, vaporware, or a scam. There may be something genuinely interesting happening here. The real question is just how revolutionary it actually is. Let's get to the biggest question surrounding Donut Lab's technology. Is it really a battery? And can those incredible specifications actually be true? When Donut Lab first announced its solid-state battery, there was very little independent evidence available. There were no detailed test results and no clear patent explaining exactly how the technology worked. That immediately raised skepticism. Some experts argued that combining roughly 400 watt-hours per kilogram of energy density with 100,000 charge cycles was simply unrealistic. Yang Hongxin, CEO of SVOLT Energy, went as far as saying the specifications appeared contradictory. Others suggested a different possibility. Maybe Donut Lab's technology isn't actually a conventional battery at all. One of the biggest clues came from Donut Lab's connection to Finnish startup Nordic Nano. Donut Lab invested in the company in 2025, and Nordic Nano has been researching advanced nanostructured materials, including titanium dioxide structures. Research involving these materials suggests they could potentially be designed with a highly porous, sponge-like structure. That could allow the material to expand and contract repeatedly without breaking down as quickly as conventional battery materials. If that approach works, it could help explain extremely long cycle life. The same kind of structure could also make very fast charging possible. With a large surface area, chemical reactions can occur closer to the surface instead of requiring ions to move deep into the material, and that is where things get interesting. The behavior starts looking more like a supercapacitor than a traditional battery. The Nordic Nano connection became even more intriguing when a company pitch deck surfaced. It described non-toxic, moldable batteries, but one of its diagrams was labeled an electrostatic bipolar capacitor. The numbers were also striking. The presentation reportedly mentioned energy density of up to around 400 watt-hours per kilogram and more than 50,000 charge cycles. Those figures are surprisingly close to Donut Lab's own claims. That naturally led to a theory. Perhaps Donut Lab is using Nordic Nano's nanotechnology or manufacturing methods to create a specialized capacitor and calling it a solid-state battery. If so, it could explain how the company is claiming such an extraordinary cycle life. But there's an important question here. What actually separates a battery from a capacitor? To understand that, I spoke with Mircea Dinca, a Princeton University professor who studies both batteries and supercapacitors. He wasn't commenting specifically on Donut Lab. Instead, we discussed the basic science behind these technologies. At a fundamental level, batteries and supercapacitors have a similar structure. Both typically contain two electrodes separated by a porous layer containing an electrolyte. The big difference is how they store energy. A battery primarily stores energy through chemical reactions. During charging and discharging, ions move through the materials and chemical changes take place. Over thousands of cycles, those materials can gradually degrade. A capacitor works differently. It stores electrical charge rather than relying primarily on chemical reactions. That gives capacitors some major advantages. They can charge and discharge extremely quickly and can survive far more cycles than conventional batteries. The downside is energy density. Traditional capacitors generally store much less energy than batteries of the same size and weight. Supercapacitors improve on that, but they still typically struggle to match the energy density of modern batteries. And that is exactly why Donut Lab's claims are so extraordinary. If the company has genuinely developed a technology that combines the energy density of a battery with the charging speed and cycle life of a capacitor, it could be a major breakthrough. but we still need to separate what is theoretically possible from what Donut Lab has actually demonstrated. The connection with Nordic Nano is certainly interesting, and the similarities in the reported specifications raise legitimate questions. But they don't prove that Donut Lab is simply using a capacitor or that the technology isn't a battery. Ultimately, independent testing will be far more important than speculation. If Donut Lab can demonstrate the claimed energy density, 5-minute charging, and extraordinary cycle life in real-world products, the technology could completely change how we think about energy storage. For now, though, there are still more questions than answers. The technology may be genuinely revolutionary, or the impressive headline numbers may turn out to describe something very different from what most people imagine when they hear the word battery. According to Princeton professor Mirza Dinka, the key difference between a battery and a supercapacitor is how they store energy. A conventional battery depends on chemical reactions inside its electrodes. Every time it charges and discharges, those reactions cause tiny changes in the materials. Over thousands of cycles, side reactions build up, interfaces change, and the electrodes gradually degrade. Supercapacitors work differently. Instead of relying mainly on chemical reactions, they store charge at the surface of their electrodes. Because there is much less chemical stress, some supercapacitors can survive 100,000 cycles or more. They can also charge and discharge extremely quickly and operate across a wider range of temperatures. On the surface, that sounds very similar to Donut Lab's claims. But there's a major trade-off. Supercapacitors store energy mainly at the surface, while batteries can store energy throughout the volume of their electrodes through chemical reactions. That allows batteries to achieve much higher energy density. So how could Donut Lab potentially combine high energy density with extreme cycle life and very fast charging? One possibility is pseudocapacitance, a technology that sits somewhere between a battery and a capacitor. It uses fast chemical reactions near the electrode surface, potentially providing better charging speed and cycle life than conventional batteries. However, Dinka remains skeptical that pseudocapacitance could reach the energy density Donut Lab is claiming. There are already commercial technologies that demonstrate this trade-off. Skeleton Technologies, for example, has developed a super battery that can reportedly charge in around 90 seconds and survive roughly 50,000 cycles, but its energy density is only about 65 watt-hours per kilogram, far below Donut Lab's claimed 400 watt-hours per kilogram. That's why the cycle life number alone doesn't tell us enough. We also need to know how those cycles were measured. Was the battery fully charged and discharged every time? How fast were the cycles? What temperature was used? And were the tests designed to represent real-world conditions? A battery tested with shallow controlled cycles could produce very different results from one used in an electric vehicle, where charging speeds, temperatures, and discharge levels constantly change. Until independent testing answers those questions, Donut Lab's 100,000 cycle claim should be treated carefully. Donut Lab CEO Marco Lettimacchi has also rejected the idea that the company is simply selling a capacitor. He has described the technology as a genuine solid electrolyte battery and says there are no tricks or misleading terms involved. According to Marco, Donut Lab began researching the technology secretly in 2018, around the same time Verge Motorcycles was founded. He also denies that Nordic Nano developed the battery. That timeline is important because Nordic Nano was founded much later, in 2024. Reports also indicate that its manufacturing plans in eastern Finland have been delayed, with pre-production expected in 2026 and full-scale production later in the year. If Donut Lab really started its research in 2018, the company would have had several years to develop the technology before making its public announcement. Marco has explained the slow release of independent test results as part of a deliberate strategy. His argument is that Donut Lab wanted critics to call the technology impossible before gradually releasing evidence to support its claims. Now, the biggest challenge is manufacturing. Donut Lab says it expects to reach about 1 gigawatt-hour of production capacity in 2026, potentially expanding to tens of gigawatt-hours the following year. Those targets are extremely ambitious. Producing an impressive battery in a laboratory is one thing. Manufacturing millions of consistent, safe, affordable cells is something completely different. There is also evidence that Donut Lab and Nordic Nano have been working together for some time. Donut Lab describes its investment in Nordic Nano as a way to accelerate development of its own proprietary battery technology. That doesn't prove Nordic Nano created Donut Lab's battery, but it does suggest there could be some technical overlap between the two companies. It's possible that some of Nordic Nano's technology could become more important in future versions of Donut Lab's battery. And this is where we have to separate evidence from speculation. Nordic Nano's own materials provide some interesting clues about its technology, and those clues could potentially help explain what is inside Donut Lab's battery, but we don't have enough evidence to say that for certain. For now, the most reasonable conclusion is that Donut Lab's technology doesn't fit neatly into the simple categories of revolutionary battery or secret capacitor. There may be a more complicated combination of battery chemistry, nanostructured materials, and capacitor-like behavior involved. The real test will come from independent testing and large-scale production. If Donut Lab can actually demonstrate 400 watt-hours per kilogram, extremely fast charging, and tens of thousands or even 100,000 cycles under realistic conditions, then this could be a genuinely important breakthrough. Until then, the technology remains intriguing, but the biggest claims still need to be proven. One of Donut Lab's most unusual claims is that it can control the voltage of its battery. Holyvolt is a Swedish company that develops screen printing technology for battery manufacturing. Its equipment is designed for large-scale production as well as rapid materials research, making it particularly interesting in the context of Donut Lab's claims. If Donut Lab really has developed a battery that avoids lithium and other critical minerals, this type of manufacturing technology could be extremely useful. Holyvolt has remained relatively private, but its CEO, Matthias Ingvarsson, has said that most of the company's 2024 revenue, around 5 million euros, came from selling manufacturing equipment. We still don't know whether Holyvolt has any direct relationship with Donut Lab or Nordic Nano. However, Holyvolt has described a screen-printed solid-state battery without critical minerals in a patent filing. That doesn't prove a connection, but the similarity is difficult to ignore. Meanwhile, Donut Lab has been releasing new performance tests conducted by Finland's VTT Technical Research Center. VTT is a respected testing organization, but there is an important limitation. Donut Lab is paying for the tests and deciding which tests are performed. That means the results are useful, but they don't necessarily give us the complete picture. Each new release has given analysts another piece of the puzzle. They've been trying to determine what the results reveal about the battery's energy density, charging behavior, chemistry, and internal design. After the first set of results, Ricky Roy from 2-Bit Da Vinci noticed that Donut Lab's fast-charging curve looked similar to a lithium NMC battery. But later high-temperature testing made that explanation much harder to support. The results appeared inconsistent with a conventional NMC battery and suggested that Donut Lab might not be using a traditional liquid electrolyte. This is why identifying the battery purely from performance graphs is so difficult. Eventually, we need to see the actual hardware. The best way to understand what Donut Lab has built will be to examine a production battery after these motorcycles reach customers. A proper teardown could reveal the cell structure, materials, electrode design, and manufacturing process. That may happen sooner than expected. Verge Motorcycles is working toward customer deliveries, although certification is still being completed in Europe and the United States. Donut Lab CEO Marco Lehtimaki remains confident about the technology. He has questioned why the company would make false claims about a product that is expected to reach the market relatively soon. And that raises an interesting question. What would Donut Lab actually gain by exaggerating its specifications? The company hasn't announced another major funding round since its €25 million seed investment in 2025. Marco has also said that Donut Lab wasn't seeking additional investment until it had completed its disclosures. There have been reports of confidential investor communications seeking additional funding during early 2026, but regardless of the financing situation, the risks of making false claims are significant. If the battery doesn't deliver the promised performance, the damage wouldn't be limited to investors. Any manufacturer building a vehicle around Donut Lab's claimed specifications would also be exposed. Designing a product around a battery promising 400 watt-hours per kilogram, 5-minute charging, and extraordinary cycle life is a major commitment. If those numbers fail in real-world conditions, the consequences could be serious for everyone involved. That's why the simplest explanation may actually be worth considering. Perhaps Donut Lab really has developed something impressive. That doesn't mean every specification will necessarily survive independent testing, but extraordinary numbers alone aren't proof that the technology is fake. In fact, Donut Lab's strategy has been surprisingly effective. The company announced extremely ambitious specifications, allowed skeptics to challenge them, and then slowly began releasing test results. If the technology proves to be real, those early criticisms could ultimately make the eventual proof even more convincing. But we're not there yet. The real test will be seeing these batteries in production motorcycles, monitoring their performance in the real world, conducting independent testing, and eventually taking one apart. Until that happens, the right position is somewhere between excitement and skepticism. Donut Lab could be on the verge of delivering one of the most important battery breakthroughs in years, or it could become another example of promising battery technology that never quite lives up to the original claims. For now, we simply don't have enough evidence to know. But that uncertainty is exactly what makes Donut Lab so fascinating. The next chapter won't be written in a press release or a laboratory report. It will be written on the road when these batteries are finally being used by real people.